Okay, again, Jeff Mucci with RCR Wireless News. We're here today with Azimuth, a wireless test and measurement company, and they're going to be discussing and presenting on bridging field tests with lab tests. Vivek, who's the Global Product Manager, will be leading the discussion today. Vivek, thanks for joining us.
Thanks, Jeff.
So we're right at 10 o'clock Central Time, 11 o'clock Eastern Time. Please go ahead and let's start the presentation. And when you're ready for me to launch the poll, because we do want to get some feedback from the audience, just let me know and I'll launch the initial polling question.
Okay.
Okay, just let me know when you want me to get started with that poll.
Yep.
Okay, again, we want to engage the audience here. You'll see a quick poll that just popped up. We'll leave this open for about 30 seconds to get some feedback from the audience. And again, this will help Azimuth guide the conversation going forward.
Okay, so maybe, yeah, okay.
So that, perhaps you go ahead and introduce yourself, and then when you're ready, we can actually start. I'll close the poll in just a few minutes, but go ahead and introduce yourself and tell us a bit about the company.
Okay. Thanks, Jeff. Good morning to all. Morning, evening, depending on where you're dialing in from. My name is Vivek. I'm the Global Product Manager for Field to Lab at Azimuth Systems. So in terms of my background, I have a background in telecom. I've been doing product development, technical standards, R&D, and product management for the last 7 to 8 years. I did my bachelor's in engineering from University of Madras, Chennai, India, and my master's from Rutgers University, New Jersey, where my thesis from WinLab was on MIMO channel modeling. As far as my role within Azimuth goes, I'm the product manager for Field to Lab. So I do two things. The first thing is, I work very closely with our existing customers, new customers, other players in the ecosystem, other test and measurement companies, drive test companies, in terms of figuring out where the market is heading and making sure that from a product standpoint we have features that our customers could use. Second thing I do is actually work with our customers very closely in terms of understanding what their problems are, what their use cases are, and then trying to figure out how we go about solving those problems.
Okay, good. Thank you. Well, it's last chance to vote on the poll. We'll keep it open for another 5 or 6 seconds here. Okay, it looks like we've got almost 100% of the folks, about 80% of the folks voting. So I'm going to go ahead and close this. Okay. Great, and now your screen should be showing the back.
Okay, perfect. All right. So that was something, that was a basic introduction about what I do at Azimuth, a little bit about my profile. As far as today's webinar goes, we'll primarily focus on how it is that one goes about bridging the really big gap between field testing and lab testing, and some specific use cases. To me, one of the most important things, we appreciate the time you spend doing this webinar. So to me, one of the biggest things that I would like you to take away from this is, one, understand a little bit about the solution, but more importantly, I would like you to take away from this the different use cases, see how you could use Field to Lab to solve the problems that you have. So the bulk of today's webinar would be focused around use cases in terms of how existing customers use Field to Lab, in terms of how in terms of some of the new features and the potential use cases they open up.
Okay, it doesn't appear. There you go. I want to make sure. I got a note here saying that your screen was not showing. I think I want to make sure it's showing. Okay, good. We got a note from the audience saying that the screen is showing properly. So go ahead.
Okay. So now we are on slide 2. So even before we jump into this whole field to lab and use cases, let's take a step back. Why do we want to do field testing? We want to do field testing for multiple reasons depending on where we are in the ecosystem. So we might want to do type approval. So what I mean by that is if I'm an operator, I might want to make sure that any device that goes on my network meets my minimum requirements. Similarly, if I'm an OEM, if I'm a handset vendor or I'm a chipset vendor and I supply to an operator, I would want to make sure that my device passes their minimum requirements. Then the second obvious reason is to address customer issues. So you deploy a new technology, you deploy a new handset, you roll out a service in a new market. You want to make sure that things work properly. And if there are customer issues, how is it that you go about addressing them? And both of these things, the fundamental goal obviously being to improve overall performance. So it is for these reasons that people typically do field testing. Now, you might ask me, so we just moved to slide 3. So you might ask me, why can't I do this in the lab? I do so much of my testing in the lab. Why is it that I can't do the things that you mentioned in the lab? Now, we can't do this in the lab for multiple reasons. If you look at the real world, it's very complex. You have so many different factors, equipment from different infrastructure vendors, different topographies, meaning you might have a place like San Francisco, a place like China, Beijing, very different geographies, and each of these actually translate to different RF environments. And to add on top of this, you have other aspects like, okay, did I build my network on top of a legacy network, or is it a network that was built ground up, the backhaul? So at the end of the day, the real world is really, really complex. You have different RF aspects, different signaling aspects. So as a consequence, most of this testing cannot be done in the lab. And one of the goals of field testing is to actually find non-standard problems. So, okay, you do 10 tests in your lab, but the moment you take your device and use it in the field, you find some issue that you were not able to catch in your lab. The goal of field testing, one of the goals of field testing is to actually catch non-standard issues that you don't necessarily catch in the lab. Slide 4, sorry. So field testing makes sense. After all, at the end of the day, we want to test devices under the same conditions in which our customers use those devices. Whether you're a handset manufacturer or an operator, infrastructure or chipset, at the end of the day, what really matters is what is the performance the end customer sees. But as we've seen, and as most of you might have experienced already, the challenge with field testing is it's very time-consuming and quite expensive. And there is no guarantee that whatever issue that you saw today, you'll be able to see it over and over again. So, put differently, with the real world, there is no guarantee of repeatability. So if I see a drop call in a particular location, there is no guarantee I'll be able to see the drop call again. Some of my colleagues actually come from drive test companies, and they've told us how, at times they've spent almost a week or 2 weeks just trying to get the issue to happen repeatably. Once the issue happens time and over again, then they have the ability to debug the issues. So, the challenge with field testing is it's already time-consuming and expensive, and add on top of that the fact that there is no repeatability. You can see how field testing becomes very, very, unwieldy. And after all, at the end of the day, the real world is dynamic, and that is one of the reasons why you don't see the repeatability under field conditions. Slide 5. So all this begs the question. So if there are we recognize the need for field testing, but we also recognize the fact that this can't be done in the lab. Given the challenges associated with field testing, how do I, as a user, deal with this? Or is there any way for us to bridge this big gap between the field testing and what you can do in the lab. And it is in this context that Field to Lab comes up. Field to Lab is an amazing solution that allows you to take the field conditions, record the field conditions once, and recreate the field conditions over and over and over again in your lab. So what this means is, if I see a drop call in a specific location, let's say I see a drop call in Times Square, I don't have to go back to Times Square over and over again to debug the issue. All that I do is collect the logs the very first time I'm in Times Square, and then I have the ability to use these logs over and over again. So there are lots of use cases as far as Field to Lab goes. These are some specific use cases, and we'll actually jump into a few more use cases later in the webinar. But as I mentioned right up front, one of my biggest goals from this webinar is for you to get a good understanding of our use cases. And if there are specific use cases that you think are of interest to you, please let us know, and we can work with you, offline in terms of, figuring out how we could use Field to Lab. So some of the use cases here are, driving globally and testing locally, meaning you can take field logs from anywhere in the world and recreate the same conditions in your lab. So imagine, in today's world, most companies are global to such an extent that regardless of whether you're an operator or a handset vendor, chipset, or an infrastructure vendor, you're always interested in markets other than just one market. So you'd be interested in US, China, Japan, Korea, different markets. So there's some way by which you could take conditions from all over the world, but test it from your comfort of your lab. Similarly, the second thing is type approval, as I mentioned earlier. So with type approval, you have the ability to actually test your device's performance under the route specified by an operator. So as we know, most operators have their own defined routes. So for you to submit a device to an operator, you need to do drive testing along those routes, collect those results, and give it to the operator. With Field to Lab, you'd be able to use those logs, use a drive log from one drive test, and do all your testing in the lab. So this way, one, it helps you save costs, and it also allows you to catch issues early on. Then the final obvious application of Field to Lab, which is to basically allow you to, recreate customer issues. Once you recreate customer issues, debug customer issues, and then come up with a solution for customer issues, and then verify the fix. So before I move into the solution, let me take a minute to talk about Azimuth. Who are we, and why are we the best person to have come up with such a solution? This is slide 6, incidentally. So Azimuth is a company, we are a test and measurement company that focuses on coming up with solutions that help customers do real-world testing in their lab. Meaning, whenever you run a test in the lab, we want to increase the chances or give you the opportunity to run tests in the lab, which give you results that are closer to what you would get by testing on the field. So we started in the Wi-Fi space, moved to cellular, and came up with the first MIMO channel emulator, the ACE-MX, which is our flagship product. And built on this wonderful platform, we have other solutions such as Field to Lab, which will be the focus of today's webinar, and RPM, our real-world performance measurement, which is our over-the-air testing solution, and even some Wi-Fi related performance solutions. Our central focus has been, as I mentioned, we started as a channel emulation company, and right now, as a company, our focus is on bridging the gap between the field and the lab. So whether it's Field to Lab, RPM, or any other solution that we come up with, the question we always ask ourselves is, how is it that a customer can use this to do real-world testing in the lab? Slide 7. So we saw what the problem was. We saw how Field to Lab can help you address this problem. So let's take a deep dive into Field to Lab at this point. slide 8. So field to lab, as I mentioned, allows you to take the field conditions and recreate the real-world conditions in your lab, real-world radio conditions. So what you see in this graphic is actually the real world. So in the real world, whether it's urban environment, rural environment, you have a subscriber, you have the signal coming to the subscriber, you have lots of obstacles around, lots of interferers around. This data is captured with a scanner. So it could be a commercial scanner like Rohde & Schwarz DSMW, PCTEL, JDSU, AccuWare XCal, or it could be with diagnostic software, say QXDM. So using QXDM, you can have your actual device plugged in, or it could be even AccuWare's XCal. So the data that you collect in the field can come from multiple sources. Now we have many customers who tell, in addition to these commercial scanners, I have my own proprietary scanner. Is there a way for me to take data from that and play it back? Yes. So we actually have the ability to take data from a proprietary data format, proprietary device, proprietary scanner, and play that back. So the data from the real world, which is captured using one of these drive test tools, is then fed into what is called as Azimapper, a software that allows us to take the drive log, extract the required information from it. Because if you look at scanner logs have a multitude of information in them. You have RF information, you have layer 2, layer 3 information, and even in RF, there's a lot of information that is contained in a scanner log. For us to recreate these conditions in the lab, Azimapper has the intelligence built into it to tell, okay, there are 10 parameters that I found in the scanner log. Out of these 10 parameters, for me to recreate the field conditions accurately, I need these 3 parameters. So I'm going to extract those 3 parameters. So that is primarily what happens in Azimapper. And we'll look at Azimapper in a bit of detail in the next slide. Once Azimapper looks at this, it creates a playback file, which is fed to our playback engine called AZPlayer. AZPlayer then takes this data and plays it back on our ASMX channel emulator. So from a customer perspective, what happens is you have the ability to take the field conditions through a scanner or a typical tool that you're using. So meaning from a process standpoint, you don't have to do anything differently. You collect drive logs as you've been doing for all these years. Collect the drive logs. And instead of you going back to the field, you feed it to Azimapper and AZPlayer, which allows you to recreate these conditions in your lab. And once you have the playback file, this is actually played back on our ASMX channel emulator. Now, before I jump into Azimapper, I'd like to show you a small video clip of some very cool visualization that we have in Azimapper. Before I show you this visualization, just to put things in context, think about this. When you get drive test logs, the drive test logs that you get might be really, really long. You might get a drive test log that is an hour long. Or if you look at many operators, if you look at their extensive drive test plans, the amount of data that you get is voluminous. So how is it that you look at all this data and focus right on the problem areas? And once you find there is an issue, how do you go about debugging the issue? What is it that can be done from a product standpoint that makes it easier for customers to debug issues? So we looked at the problem from that perspective. The moment I know there is an issue, how much time does it take for me to go from identifying the issue to actually figuring out the source of the issue? And one of the things that we found time and again was, having access to strong visualization, very intuitive information makes it easier for you to figure out the source of issues. So one thing you would find from an Azimapper standpoint is we've got really, really good, really cool graphs. And the goal here is, one, it makes it easier for you to visualize graphs, but visualize information, but more importantly, from the moment you find an issue, we want to short circuit the amount of time it takes for you to go from identifying an issue to actually figuring out the source of the problem. So I'm actually playing back a video, and what you should actually see is how the field conditions vary. So this is basically a drive log that we collected in Dallas. what you would see is at each point in time, we show you what the RSRP is. We show you which sectors are there. And the reason this is important is the moment I see a drop call, so looking at this graph, you see the green balloon or the bubble. So let's say I see a drop call there. Instead of me looking at QXDM or looking at some other tool and figuring out what happened around that point in time, by looking at Azimapper, you'd be able to tell, okay, a drop call happened at point X. At point X, this is the RF information. So this way, the moment there's an issue, it makes it easier for you to figure out where the problem is. Moving on. So we are right now at slide 10. Azimapper. So as I mentioned earlier, Field Lab consists of two pieces. You have something called Azimapper and AZPlayer. Azimapper is the first piece of software, and what this basically does is it takes a scanner log or a diagnostic monitor log and extracts all the important information from the scanner log. The reason Azimapper is important is, one, it allows you to actually take existing scanner logs and extract the useful information that is there in it. And what we do from an Azimapper standpoint is we work with all the commercial scanners that are out there in the market. We understand each of their file formats, and we know how to extract the information from that. So what that means for you as a customer is, when you are using a particular scanner, you don't have to worry about, oh, the scanner X went from version 1 to version 2, so what does this mean from a file format change? You don't have to worry about that. We work with the scanner company so that from a customer standpoint, new software versions, new features, everything should be transparent for you. It's as simple as taking a scanner log and importing it into our Azimapper software. Once we import the software, we do lots of intelligent processing with the data we get from the scanner log for multiple reasons. One, in some cases, you might find that the data you get from a scanner log doesn't necessarily include everything you want, or maybe there might be some missing samples. Or in some other cases, we actually use proprietary algorithms to enhance the data we get from the scanner logs. The reason this is important from your perspective is, whenever you collect data, this way you're guaranteed that instead of us just playing back the data that is there in the scanner log, we build enough intelligence around it. We extract the information intelligently so that when we recreate the conditions in the lab, you have the guarantee that you'll be able to recreate the same field conditions as what your device are. And in addition to this, as I mentioned earlier, there are lots of visualization capabilities built into Azimapper. And I'll actually show you some of the use cases. We actually have some customers who started using Azimapper not only for extracting log files or creating playback files, but just to visualize. The moment they see an issue on the field, the first thing they do is take the scanner log, put it in Azimapper, look at some graphs, and then decide whether they want to play it back. So the takeaway here is Azimapper is a very powerful, intelligent engine that you can use to take a scanner log, prepare it for playback, or even use it for debugging field issues. Moving on, slide 11. So the second piece of Field Lab is what is called AZPlayer. Azimapper takes a scanner logs and creates a playback file based on settings you specify. So you might tell that I have 2 sectors in my lab, I have 3 sectors in my lab. So based on the settings you specify, Azimapper takes the field log and creates a playback file. This playback file essentially contains information such as power levels, your correlation matrix, propagation delay, velocity, any important RF characteristics. So it's basically a time evolution file which shows at time 0 this was the power, time 10 milliseconds this was the power. This entire playback file is then sent to our ASMX, which recreates the field condition. Now the beauty of AZPlayer is it was built ground up primarily for field lab like applications. So what that means is it gives us, from an architecture standpoint, it's been designed so that there's no need for you to compile files. So what that means is the moment you export a file from Azimapper, it's as simple as hitting play. You don't have to compile the file. It's instant play. Second thing is also that there's no limitation on the size of the file you play back. So think about it. When you have drive logs, you have drive logs worth hours and hours. When you want to play it back in the lab, it becomes a very constricting factor if you find that there is a restriction on the size of the file. Which is why from an AZ player standpoint, there is no restriction on the size of the file. So if you're going for a long weekend, you can line up a couple of files and you can run tests for 3 days, 5 days. We actually have customers who run tests continuously for 2 weeks to see how infrastructure equipment performs after X weeks. In addition to the strong capabilities that we discussed right now, we also have some ease of use. One of the other things that's very, very central to Field to Lab, or for that matter, even our Azimuth core products, is ease of use. Because at the end of the day, as a user, you don't want to spend time configuring test equipment. Your goal is to finish your task, whether it's debugging an issue or running a test. So from a Field to Lab perspective or any Azimuth product perspective, the goal is, let's make sure that we make it easy for the customer to set up the system and run the test and spend more time on things that they really want to do. So from that point of view, we do things such as input power tracking, meaning whenever there are power variations, the power that you get from the base station varies depending on the number of UEs that attach. Now, instead of expecting the user to figure out how the power has varied and change the input power settings, we do all these things automatically. What this means from a customer standpoint is, as a customer, you don't have to worry about these details. As a customer, all that I do is choose the file I want to play back, hit play, and you're good to go. Before we go into some use cases, I wanted to talk about the last piece of Field Lab, which is the AceMX. So as I mentioned briefly, AceMX is a MIMO channel emulator. The AceMX was the first MIMO channel emulator in the market, and it is not that makes the AceMX unique. One of the things that makes the AceMX really unique is its support for bidirectionality, meaning the box is fully bidirectional. So what do I mean by that? When you run tests in the lab, how do you run tests? You have a base station or a base station emulator, you have a channel emulator, and you have a UE. Now, when you run a test, you have both the uplink and downlink going between the base station and the UE. With the AceMX, because of its bidirectional design, all that you need to do is take a cable from the base station, hook it up to the channel emulator, take a cable from the channel emulator, hook it up to the UE. All the splitters, isolators, circulators that you require to split the uplink and downlink and keep them isolated is internal to the AceMX. What this means from a customer standpoint is, whether you're doing a simple test where you have just fading on the downlink, or if you're doing a complex test where you have fading on your uplink and downlink, you don't have to worry about hooking up external components. And all of us know that not only do external components cost extra money and degrade performance, but it's also a logistical nightmare. So if I'm testing a particular band, if I'm testing a 700 band, and I want to move to the 2100 band, I cannot just switch frequencies. I need to see whether the external components support the new frequency, change the components, and then go about doing my testing. The AceMX eliminates all these things. From a customer standpoint, you just choose the frequency that you want to run, hit OK, and you're good to go. So what we've seen so far is the need for field testing and the problems with field testing and how Field to Lab can help you address that. And up until now, we've looked at Azimapper and AZPlayer. Slide 12. So as I mentioned, one of the use cases for Field to Lab, apart from actually recreating field conditions, is actually profiling and visualizing, meaning using the powerful visualization capabilities that are there in Azimapper visualize the information that you see. So, okay, I have a drive log collected in a particular area. How do I visualize that information? What do I make of this drive log? And if I see issues in a particular area, is there any profile, or is there any information from RF standpoint that explains why is it that some areas see more issues than other areas? So this is a very big use case from an FTL standpoint, and we'll look at some specific graphs or some specific visualization use cases from an FTL standpoint. And again, because of the amount of time that we have, I'm just going to go over some very specific use cases. But then, if you'd like for us to go into detail into other use cases, please reach out to us, and we're more than happy to talk to you about some of the other use cases from a visualization and profiling standpoint. Slide 13. So what you see here is the ability for you to profile routes. So what do I mean by profiling routes? By profiling routes, when you do drive tests, you don't do drive tests just in one place. You do drive tests in multiple locations. So today, if I were to ask you, if someone were to ask you, which two cities should I do drive tests in, there is no easy way or no scientific way for us to tell, okay, I need you to do a drive test in San Francisco and San Diego because of reason X. Typically, most people, including myself, we always tell, oh, I want you to do a drive test in San Diego and San Francisco because I think those two places are geographically, the topography is different, which makes sense. But after a particular point, it becomes very difficult for you to tell, oh, which two cities do I choose? Or even looking at a different use case, if I actually tell, I'm seeing lots of issues in a particular market. I'm seeing a very good throughput in market A, but the throughput in market B is not very good. There's no easy way for you to put your finger on something and tell, okay, this is the reason why I think it's happening. And this is a problem that many of our customers have had, which is the reason why we came up with this very powerful profiling feature in Azimapper. And what this allows you to do is, whenever you look at a particular drive log, you'll be able to look at a combination of things. Look at the distribution of RSF, you look at the distribution of number of sectors and other critical parameters. And based on that, you can tell, okay, this is urban macro, this is urban micro. Or you can even come up with your own set of profile buckets. So we've actually worked with some customers where we've created custom profile buckets for them. What that means from a customer standpoint is, one, it allows you to optimize your drive testing. So instead of you doing drive tests in 5 different places because they're 5 different cities, you can actually look at the data from those cities and tell, okay, how diverse are they, how different are they, and based on that, do your drive testing. Second thing is, if you see an issue in a particular location, you'd be able to tell, okay, I see bad throughput in the Dallas area because if you look at the typical distribution of RSRP, the RSRP is very low, the interference is high, and I think that is the reason why the performance I see in Dallas is worse than the performance I see in maybe Austin. So this is one use case for field to lab. So basically, it allows you to profile channel conditions across multiple routes. And what you actually see here is data that was collected in Boston, New York, rural Massachusetts, and rural New Hampshire. And as you can see, each of these have a very different profile associated with them. Slide 14. So we saw how you can profile the environment. But the other thing that most people are also interested in is profiling the performance. I'm sorry, I think my internet connection is a little patchy, so you should see slide 14 up right now. Okay, so from a customer standpoint, one thing that you're interested in is the RF environment. Second thing is performance. You want to know that, okay, if I'm seeing bad throughput, why do I see that bad throughput? Is the bad throughput that is something that happens through the entire log, or does it happen during specific pockets? So what you actually see here is the ability for you to profile the performance of a device. So whether you're interested in throughput, drop calls, blur, any metric of interest, you have the ability to visualize it as a function of your RF environment. So in this case, I just plotted a graph that shows how throughput varies with the total RSSI seen by the device. Now, this throughput was plotted for a single device, but think of it, when you're running tests in your lab, if you're an operator or a chipset vendor or even a device vendor, you'd be interested in seeing how your device performs across your competition. Or even if you have two different versions of the device, you might have firmware version 1 of your device, and you want to see how throughput of that varies when compared to firmware version 2 of the device. You have the ability to subject all these devices to the same RF conditions and see how each of their throughput varies. Now, the coolest thing about this is not the fact that you have the ability to profile your performance, but the fact that this can all be done at the click of a single button. So, what the last piece I'll talk about from a field lab standpoint is our automation platform called Test Builder. And the graphs that I show you here were generated using Test Builder, where we just hooked up Test Builder connected to a device automatically, started pulling out the throughput numbers, and it plots it out as a graph. So what I would like you to take away from this is using AZ Player and our automation platform, you'll be able to, 1, profile the performance of a device as a function of the RF environment, and 2, even benchmark multiple devices. Slide 15. So the last use case, this is something that which I touched upon earlier, but it gives you the ability to visualize routes. And as I mentioned, the reason this is important is when you see a drop call or when you see a throughput issue, typically you're interested in the information that happened around that. Or you want to know, if I see a drop call, what led to the drop call? By actually allowing you to visualize the location-specific information, meaning the RF information around each point on the drive route, it makes it easier for you to debug issues, visualize, or explain the results that you're seeing on the field. So these are some specific use cases that we saw from a field lab or visualization or profiling standpoint. Now, you may tell me, okay, this all sounds good. Can you talk about some very specific use cases? Can you tell me how a customer saw an issue on the field and how they were able to recreate it using field lab? So I'd like to talk about 2 very specific use cases. How did customers use field lab to debug the issues that they were seeing on the field? The first thing is something we call a rising pilot. So a rising pilot. So we had an operator customer whom we were working with who was seeing drop calls in a specific location. They were seeing drop calls, so then they did some drive tests in those areas, and they saw that they were seeing drop calls on a very specific UE. So then they thought it was a UE issue. They reach out to the handset vendor and tell them, I'm seeing a drop call in this specific location over and over again. Can you debug this issue? The handset company then decided they were going to start looking into it, so they also started doing some drive testing. Now, when they did some drive testing, they found that the drop call was happening because of what we call a rising pilot. So if you actually look at the graph, so you would see 2 graphs here. If you look at the second graph, right towards the tail end, you see this red section, a red rising pilot. So that was basically what was happening. So this was collected in a downtown area. And as the user was going down a road, the user came to an intersection, and down the intersection, 90, orthogonally to where the user was, there was another base station. So what was basically happening was when the subscriber was driving down a road, they briefly crossed another base station. And when they crossed the base station was so strong that the UE tried to move to that base station. But the subscriber then passed the intersection, and they no longer were in the range of the base station, and that is the reason why the drop call happened. Now, using field lab, this customer is actually able to solve this problem faster than what it would have taken for them if they had relied just on drive testing. So these guys saw there was an issue. The operator got the handset vendor involved. So what the handset vendor did was, once they collected a drive log, instead of them going back to the field over and over again, debugging the issue and figuring out what happened, they actually started debugging it in the lab using field to lab. And what they found was there was actually an issue with the chipset. They got the chipset vendor involved. They were able to debug the issue in the lab, fix the issue in the lab, verify the fix in the lab, and then go to the field. So what I would like you to take away from this specific example is, one, it gives you the repeatability, because if I saw an issue on the field and if the issue was not repeatable, it's going to take you a lot of time before you even come to a point where you're recreating the issue consistently over and over again. So it gives you that repeatability, which is very critical for solving issues. And two, it significantly reduces the amount of time it takes from the point an operator finds an issue to the point where the issue is solved. Because let's look at the case. Let's look at a case if the handset company didn't have field to lab. So if I'm a handset company and I don't have field to lab, what happens? The operator reports an issue, and it takes some time before the operator, handset vendor, infrastructure vendor figure out whether it's a UE issue or a base station issue or a network issue. Once it has been figured out to be a UE issue, then the handset company goes to the field, does drive testing over and over again. And if you're lucky, that's a big if, of course. If you're lucky, you recreate the issue, you collect some logs, you try to debug it on the field, and then you ask the chipset company to come to the field, recreate the issue, they fix the issue, then you go verify the fix. So as you can see, if you rely just on drive testing, the amount of time it takes for you to go from seeing there is an issue to actually fixing the issue is really, really big. And field to lab allows you to significantly reduce the amount of time it takes for you to do this. And the beauty of field to lab from this perspective is not only that it allows you to actually pick up this issue and solve this issue, but the next time I come up with a new firmware version, or the next time I come up with a new handset, if I'm an operator, what I would do is I would tell, okay, the last time I had this issue with a particular phone, so the next time any phone comes to my lab, before I actually put it on the network, I'm going to subject those UEs to these conditions using field to lab and make sure that this issue doesn't happen. So using field to lab, not only does it reduce the amount of time, but it also gives you, in some ways I almost look at it as gives you greater value for drive logs. So once I have a drive log, you have the ability to use it over and over again and make sure that the next time you deploy a new device or the next time you have a new firmware version, this issue doesn't happen. Slide 17. So on slide 16, we spoke about a use case called Rising Pilot. On slide 17, this is a very, very cool use case, one of my personal favorites actually. Here again, it was a drop call, but this drop call is happening due to different reasons. So we were working both in Asia and Europe with some customers who are very interested in testing performance of devices under high-speed train conditions. So this operator that we were working with actually saw lots of drop calls and throughput issues under high-speed train conditions. Now, you might ask me, that doesn't make any sense because doesn't 3GPP have a high-speed train testing scenario? Yes, you're right. 3GPP has a high-speed train testing scenario, but the high-speed train testing scenario in 3GPP it's a basic functional test. It's a basic functional test to make sure that the UE and the base station can handle the shifts in Doppler. Now, when you look at the real world, the real world conditions are much more complex. It's not just the Doppler that varies in real world. In real world, what varies is the Doppler. You have your power conditions that vary multipath. So you have a multitude of factors or multitude of impairments that actually are thrown at the UE. And this is the reason why, whether it's high-speed train or even basic testing, this is the reason why you oftentimes find that no matter how much of testing you do in the lab with standard channel models, the moment you take the device to the field, the performance that you see on the field is really, really different. So with this customer, what they were able to do was they were able to use field to lab, record the field conditions in the areas where they were seeing problems, bring it back to the lab, and recreate the same conditions. And by recreating the same conditions, they were able to debug the source of the issue and fix the issue. here again, in addition to the time and cost savings, it's also the cost savings, because if I'm someone based in the U.S. and I have to send someone out to Asia or Europe each time to debug issues, you can think of the direct cost in terms of money you spend and even the opportunity cost. So Field2Lab allowed this particular customer to save both time and money using by allowing them to recreate the conditions in the lab. And at the bottom of the slide, you'll actually notice a very forward-looking use case for this specific application. So the other thing that Field2Lab allows you to do is, once I have a drive log, once I collect a drive log, Field2Lab allows you to actually modify this drive log or extend this drive log to create new conditions. So what do I mean by that? So let's look at this specific example. If I'm an operator and I know and I want to build a network, deploy a network to support high-speed trains, and I know that 2 years from now, the local trains, there are going to be trains that are going to be going 100 miles faster than what they are going at today. So when I'm designing my network, I want to make sure that I design my network for the trains that are going to go at 400 miles per hour, assuming we have trains going at 300 miles per hour today. How do I do that? Today, there are no trains going at 400 miles per hour. So how do I design a network, test my device, and make sure that my device performs well? It's not that you can go to the train operator and ask him to run the train faster. You don't have that option. So we are actually working with this a specific customer who's using Field2Lab to simulate faster trains. So they basically collect drive logs from the field with trains that go at 300 miles per hour, and then they use Field2Lab to accelerate this to simulate the effect of faster moving trains. Now, this is a very specific use case that I spoke about from a high-speed train perspective. You may not have to deal with high-speed train, but what I would like you to take away here is, if you see a particular environment, let's say you're interested in testing a particular band which is not allowed in the local geography, you'd be able to do that using Field2Lab. So using Field2Lab, not only do you have the ability to recreate the field conditions, but you also have the ability to take a field log and actually modify it or tweak it as per your needs to create new field conditions. So the last piece that I wanted to talk about from a product standpoint was our automation. So as I mentioned earlier, we have something called Test Builder that allows you to automate and run tests. So I wanted to spend maybe a couple of minutes to talk about that, because I think it's very, very important to have something that allows you to run tests over and over again. I mean, if you look at the equipment that you have in your lab, how is it that you get maximum value out of the equipment? You have hundreds of UEs that you need to test. So it's very obvious that there needs to be some way to automate this. And Test Builder is one platform that would really help you to automate your entire testing. Slide 19. So what you see in slide 19 is a screenshot of our automation platform called Test Builder. So Test Builder is an open source platform that allows you to control not only the Azimuth box, but even other equipment. You can control handsets, you can control base station emulators, you can control spectrum analyzers, power sources. Why did we do this? I mean, if you think of your lab, if you think of the equipment you have in your lab, you don't have equipment from a single vendor. You have equipment from multiple vendors in your lab. And if each vendor just gave you access, a particular DLL that automated their automation platform, then it becomes your job. The onus falls on the user. The onus falls on the customer to actually recreate, come up with an automation platform that allows them to control all these pieces of equipment. Which is why when Azimuth looked at it, we told, let's come up with an automation platform that allows customers to automate not only the Azimuth box, but even other pieces of equipment. So the other thing that makes Test Builder really unique is the fact that it's not a coding platform per se. So as you can see from the screenshots, it's a drag and drop platform. So we have all these modules. So you see this thing called the toolbox. Under that, you see lots of modules, and these modules are for Azimuth equipment, other equipment, commonly used equipment, tools such as Chariot, QXDM, TEMS. So it comes pre-populated with all these modules. And now you might tell, what if I want to create my own module? Yes, you can create your own module. In fact, we have customers who've literally given up on any internal automation and totally embraced Test Builder and created their own automation platform. Now, using Test Builder, what you could do is automate your entire testing, meaning right from the point of setting up a call. So we have customers. I'll talk about a specific customer. So we have a handset customer who does lots of competitive benchmarking using Test Builder. What they do is they have a Test Builder test, which is just a string of modules put together. And what this basically does is it kicks off QXDM. Once it kicks off launches QXDM, connects to the multiple devices, sets up a call, so initiates call on all of these devices. Now, this call can be just a data call, it can be a voice call, or for those of you who are interested in multi-rap testing, it can be a voice plus data in any sequence that you want. They set up a call, and once the call has been set up, initiate logging on QXDM so that you have the QXDM logs to look at, collect throughput, blur, drop calls, or any metric of interest. And everything is plotted using Test Builder. And you have all these results plotted using Test Builder, and each time you go through the entire test, the call is then toned down, the QXDM log is saved, and then you move to your next test. So this way, what this allows you to do is not only does it allow you to automate your entire test, but it allows you to do extended testing. So if you go on a Friday night before I go off, I put 4 or 5 Test Builder tests one after another. So this way, I can test New York, San Francisco, or maybe Beijing, Tokyo, different routes, and everything is done automatically. And the results are generated in the form of, it can be a report, it can be screenshots. And in fact, many of our customers find that using Test Builder, they have these reports that they use, one for internal meetings and 2 for customers. As a handset vendor or a chipset vendor, you can run tests on a particular route. So if an operator tells, I want you to collect logs for a user going from New York to Boston and collect the drive logs and show me the results. Instead of you actually having to do the drive test, you'd be able to take the drive log for that route, play it back using Field to Lab, collect the results using Test Builder, and just send the report to the customer, report to your operator. So we saw what Field to Lab was. With Field to Lab, you have the ability to recreate field conditions, and this allows you to debug issues faster, do regression testing. So whenever I go from one firmware version to another firmware version, you can see if things have been broken, you can see how performance has changed. You can do competitive benchmarking, and you can even do advanced prototyping. Now, what does this all mean from a customer standpoint? I think it's very important that, as a test company, as a test company, it's very critical for us to see what this means from a customer standpoint. What does it mean to you? And there are a few things that are very obvious. It leads to significant cost savings. It gives you repeatability that you don't have with the real world. To me, one of the other things that really that Field to Lab really opens up is time to market, meaning significantly reduces the amount of time it takes for you to debug issues or even come up with, go through your product development. We are in fact working with a particular chipset vendor who started using Field to Lab as a part of their product development. The reason they do that is because instead of them going through their entire product development and then doing field testing and realizing there's an issue, they want to catch issues early on because, as all of us know, it's easier to fix issues early on in the development cycle. So it significantly reduces time to market. And this is very important because if you look at today's market, there are so many new devices that come out. And if it takes me just 6 months to go through my entire field testing, it gives my competitors time to come into the market. So it significantly reduces time to market. And it also allows you to automate. This automation is very, very critical because, as I mentioned, whether you're an operator, handset vendor, or a chipset vendor, the number of tests that you need to run on the number of devices you need to deal with is really, really large. So if there's some way for you to automate it, it makes testing a lot easier. And Field to Lab has very strong automation capabilities, some of which that we saw that allow you to get through this testing more efficiently. And one of the other things that Field to Lab also opens up is what I call a security. And what I mean by that is, each time you come up with a prototype device, let's say you come up with the next killer phone, you don't want your competition to know about it. So if there's some way by which you could do your testing in the lab without you, if there's some way for you to do the testing in the lab without there's some way for hello? Okay. Sorry about that. So if there's some way for you to do the testing in the lab without your device having to go out, that would be really, really, that would be really powerful. So that is another use case. We have some customers who tell, I have this specific device and no one outside my team can see what's going on. In that case, they collect a field log and they have the ability to retest the device as though the device is really out in the field. And we actually polled some of our customers and asked them, okay, you've been using Field to Lab for the last 3 years. How much has Field to Lab actually helped you save in terms of drive testing costs or time to market? And some customers have been able to realize more than 30% gains using Field to Lab. And the thing here is, from a customer standpoint, it's not just you who could be saving so much. So think about it. With Field to Lab, it allows you to save time and money, but it also translates, or it also pushes out these savings to the entire ecosystem. So if I'm an operator and I was using Field to Lab and I had my handset vendor also use Field to Lab, what it allows me to do is the next time there is an issue that I see on the field, instead of asking my drive test instead of asking my handset company to go to the field, I can just take the drive log where I saw the issue, give it to my handset company. The handset company then uses Field to Lab to recreate the same conditions. So it gives you this entire platform, or it pushes a sense of consistency throughout your ecosystem. So the savings that you see translate to not only you, but to your entire ecosystem. So to wrap it all up, so what have we seen so far? And what are the advantages of Field to Lab? So I went over some of the advantages of Field to Lab. We have very good automation capabilities, strong visualization, strong and intuitive visualization features, real-time streaming, support for MIMO. So we have support for SISO, MIMO, support for up to 16 sectors, ability to do downlink and uplink fading. So the takeaway here is, from a Field to Lab standpoint, technically it's a very, very strong product. I mean, after all, we've been in the channel emulation space for a long time. We do complex technology. So from a technical standpoint, the product is amazing. But in addition to that, from a customer standpoint, whether it's ease of use or visualization, we've got a great lens to make sure that the product is something that not only gives you, that is not only technically competent or technically accurate, but even easy to use, even for a novice user. So to summarize, we saw how field testing was important, and there are challenges associated with field testing. So there is a very strong need to bridge the gap between the Field to Lab, and Field to Lab allows you to do that. And we spoke about some specific use cases. So you could use Field to Lab for operator type approval testing. So if operators have specific routes where tests need to be run, whether I'm an operator, handset vendor, or a chipset vendor, I can do all these tests using Field to Lab. Other thing is you have the ability to troubleshoot issues. So whether it's issues that you see in your local market or issues that you see globally, you have the ability to recreate those issues and debug those issues using Field to Lab. and you have the ability to competitively benchmark. You have the ability to do competitive benchmarking of devices too. So Field2Lab has lots of use cases. We spoke about two specific use cases, and as I mentioned a couple of times during the webinar, if there are specific issues that you're seeing on the field and you'd like to know how Field2Lab might be able to help you, please reach out to us, and we are more than happy to talk to you in detail about how we think Field2Lab can help you address those issues. So with that, thank you for joining us today. Thanks.
Thank you, Vivek. We do have time. I'd like to take a question or two, but before I do, I wanted to share the results from the poll earlier about folks' feedback on benefiting from the tools. And you can see that over 87% of the folks would see some benefit for more effective use of drive test capability. And I do want to maybe follow up on one question in terms of how Field Test Labs helps create a common reference environment for evaluating different solutions.
Yeah, definitely. So, so when it comes to this, I'll talk about a specific use case, because I think at the end of the day, talking about specific use cases makes it easier to understand, how it can be done. So we had this operator who wanted to evaluate different base station solutions, and they had different base station infrastructure vendors supplying equipment to them. And by having their entire ecosystem, so the operator was using Field2Lab, and the two base station vendors they had were also using Field2Lab. What the operator was able to do was collect a drive log from the field, give it to both the base station vendors, ask them to run the same set of tests. So, as I mentioned, with Test Builder, you have the ability to create tests. So what the operator actually did was, not only did the operator share the field log with the infrastructure companies, but the operator actually shared even the Test Builder test. So thereby ensuring that when they were comparing the two solutions, they were literally doing an apples-to-apples comparison. So they took a drive log, they took a Test Builder test, gave it to both the infrastructure companies, asked them to run a set of tests and give the results. And by looking at these results, the operator was able to tell, okay, under the same conditions, infrastructure 1 gives me better results than infrastructure 2. The other consistency that this delivers was what I had alluded to earlier, where if I'm in an ecosystem, you have operators, chipset vendors, handset companies, and infrastructure vendors. So the moment there is an issue, there's lots of interaction that happens between all these parties. The moment there's a drop call, it takes some time to figure out whether the issue is with the base station, the UE, or the actual network. We in fact worked with an operator who told that sometimes it took them a month and a half just to figure out where the problem was. And once they figured out where the problem was, it took them another month and a half to 2 months before the problem was resolved. So with some of our operator customers who use Field2Lab and pushed out Field2Lab throughout their ecosystem, they've seen Field2Lab make a very big difference here, because the next time they see an issue, all that they do is take their drive log, give it to both their chipset, give it to both their handset and infrastructure customer, ask them to play it back in the lab, and figure out whether it's a handset or a network or a base station issue. So these are some specific use cases where Field2Lab helps deliver the consistency throughout your ecosystem.
Okay. Well, I have one more question, but before I do, I want to launch the final poll and just leave it open for a few seconds so folks could respond. So bear with me 1 second, Vivek.
Yeah.
So the next question is, if you could successfully replicate field conditions in your lab, would you rather test in the lab or in the field? We'll leave this open for 20 or 30 seconds. And while it's up, I'm going to ask Vivek a question we got from the field. And the question is, how do you verify results, whether they're correct or not? Some of the questions explained as an example may not exist in the real world.
Right. So, I mean, that's a very good question, and I think most customers ask us that, right? Because what we're basically telling you is that next time, instead of you going back to the field, once you have a field log, replay it in the lab. So we do multiple things from a core product standpoint. Each time we add support for a new technology, or each time we add support for a new scanner, we do a thorough analysis. We collect lots of drive logs. We play the drive logs in the lab. Collect a drive log, recreate the conditions in the lab, look at the conditions in the lab and compare them to the field conditions. So that is the very first step. Making sure that the field conditions or the conditions that we create in the lab match closely to what we saw in the field. So that is the first step of verification that happens. Second step of verification that happens is sometimes we see a particular issue on the field. So what we do is, okay, now I know my platform or the algorithm I use is bulletproof. My second thing is, if I see an issue on the field, let me collect some drive logs around that particular issue. Maybe I see a throughput issue on the field. Let me come back to the lab and see if I can recreate that issue. That is the second thing that we see. So we look at the distribution of drop calls that you see on the field versus distribution of drop calls that you see in the lab, compare the two of them. And the third thing that we do is this advanced thing that you were talking about, where if I'm a customer and I tell, okay, I want to take your drive log and I actually want to modify something, how do I know whether that's even legitimate? And I think that's a very fundamental question, because if someone were to dial up the noise to a really high value and get some results and go show it to their ecosystem accounts and tell, okay, I saw a drop call under these conditions, most people would ask the question, okay, where in the real world would you see something like this? And in that case, it's typically a very consultative process where, based on our experience, we work with lots of companies and we have lots of drive logs. Typically what happens is the moment a customer tells, try something like that, in most cases we work with customers and tell, okay, if you're interested in testing high interference scenarios, we would recommend that you go up to this particular value because this is what we've seen typically on the field.
Good. Okay, we're out of time. Vivek, thank you so much. We'll remind everyone that you can submit questions directly, and the contact information is here on the slide. And if you have any questions for RCR or interested in doing a webinar in the future with us, please reach out to me directly at jmucci@rcrwireless.com. Vivek, great job. Thank you so much for joining us today.
Yep. Thank you.